All right, I haven't tried to film one of these this way before. We'll see how this goes. So I'm going to start out with what our goals for today are. We've been talking about quadratics. Our goal is, given a quadratic function, we want to be able to identify the locations of the axis or line of symmetry, the location of the vertex, the location of the y-intercept, and we're going to pick up one extra point that's related to the y-intercept as we go. Okay, so that's what we're shooting for. Shift over to another board here. Okay, so first thing we need to know is all of this is going to be based on getting our quadratic into standard form. So we're going to have no parentheses or anything like that. Everything's going to be something times a squared plus something, or something times x squared plus something times x plus something times c. These are called the coefficients. Right, coefficients are the number in front, and we are strictly focusing on the part that is a number. Okay, not on the variable part. So the first thing we're going to do is practice. I'm going to give an example problem. So here is my example problem. So my example problem is going to be g of x is equal to 8 minus 12x plus 3x squared. I'm throwing this one in here because we can't just look at these numbers in the order that they show up. The a is always supposed to specifically be the quadratic coefficient, the number that's in front of the quadratic term. So if I rewrite this in standard form as 3x squared minus 12x plus 8, then now I can read them in the order that they show up. And I'm going to identify that my a in this case is a 3, the b is a negative 12, and the c is an 8. I do not include the x's in there. Okay, this 3 is just a 3. The squared is on the x. The squared is not on the 3, so this is just a 3 that's there. If I try to include variables in there, it's going to be a disaster later. Okay, so let's see. Second example here, I'm going to go with y equals negative x squared minus 6x plus 13. This is in standard form. My a in this case, I'll just separate these two problems, is going to be a negative 1. I don't see the 1 there, but that's what lazy mathematicians do, right? If it's 1 involved in a multiplication, we don't need to write it. The b is negative 6. And the c is 13. Okay, not difficult. Shouldn't be difficult to get those and write them down. And so now we're going to make use of those things. Okay, shifting boards again. So this one is about finding the axis of symmetry. Axis of symmetry has a particular equation. For the sake of the video, I'm going to darken that in here. That's x equals the opposite of the b that we found earlier divided by 2 times whatever the a is. So in my examples, my first one is going to be x equals the opposite of fraction bar and the 2 underneath. Those stay the same all the time. My b value in the previous one was a negative 12, and the a value was a 3. So that's the opposite of negative 12. I guess if I'm simplifying that, the opposite negative, those things are going to give me a 12 divided by 2 times 3, which is 6. 12 divided by 6 is 2. This is the equation for the axis of symmetry. In Algebra 2, we'll show you why that's the equation for the axis of symmetry. In Algebra 1, we're just going to give it to you so that you can use it. Okay. In my second example, again, x equals opposite of, and I get the 2 there. Don't forget this opposite of, because if you lose track of negatives, everything's going to be wrong that you do. Okay, my b value was a negative 6, and my a value was a negative 1. So I get I got that opposite negative there again. That's not always going to happen, but it happens in this one. 2 divided by negative 1 is negative 2. 6 divided by negative 2 is negative 3. So that is the equation of my axis of symmetry for my second example. Pretty easy to find overall. So, now the one that's got the most work to go along with it. We're going to work on calculating the location of the vertex. What we know is that the axis of symmetry passes through the vertex. So that x equal 2 and x equal negative 3 that we just found, okay, x equals 2, I'm going to do the other one on another board over here, record that for now, means that the coordinates of the vertex are 2 comma something. 2 is the input, okay? And so my equation from the beginning looked like g of x equals, and where I had x's before, I'm going to leave empty sets of parentheses right now. I had 3 times something squared, let's see, minus 12 times something plus 8. And so what I'm going to do is drop these 2's into all of those where the x's were because I want my x to be 2. Okay, this part over here, g of 2 is just telling me, if I read this, the output of the function g when you input a 2 can be calculated in this way. So let's simplify those things. Order of operations says the exponent happens first, so that becomes 3 times 4. 12 times 2 is 24, plus 8. This is 12 minus 24 plus 8. 12 minus 24 is negative 12, plus 8 is negative 4. And so the location of the vertex of that first example is 2 comma negative 4. Okay. If we look at the second one, already said x equals negative 3 was where the axis of symmetry was. So my vertex is going to be at negative 3 comma something. My second equation looked like y equals the opposite of x squared minus 6 times x plus 13. And we're going to drop negative 3's into those empty sets of parentheses. And then follow order of operations there. This is going to be the opposite of negative 3 squared is positive 9. So the opposite of positive 9 is negative 9. I've got a negative, that's going to be plus 6 times 3 is 18, plus another 13. This is 9 plus 13, which is 22. So the y-coordinate of the vertex is 22, and that is the location of the vertex for my second parabola. Again, that second one was y equals negative x squared minus 6x plus 13. So far, I know where the axis of symmetry is. I know where the vertex is. That's good information to have. Okay? Last bit of what we're going to look at here. Okay? We're going to look at, first of all, finding the y-intercept. I'll darken this in again. My y-intercept is on the y-axis, which means the x-coordinate is always 0. I always find y-intercepts by making x is equal to 0. Okay. And it turns out in my standard form, if I plug a 0 in for the x's, then the linear and quadratic terms disappear, and all I'm left with is the constant term, which I called c. Okay, so my y-intercept for the first one, you may have been wondering why we named the c and haven't really used it. The y-intercept for my first example, which again was, I'll put that up here, I called it g of x. And g of x is 8 minus 12x plus 3x squared. Zeros in for the x's leave me an 8. So I know the point 0, 8 is on that graph. It is the y-intercept of that graph. My second equation again was y equals negative x squared minus 6x plus 13. And so 0, 13 is where that y-intercept was. Clean that up. Okay, that's nice. I know where my vertex is. I know the axis of symmetry. I know that point. But what I'm able to use that for, right, my axis of symmetry on this first one was at x equals 2. So I'm going to draw the picture of this, even though in practice I'm probably going to be able to get away with not using the picture. Okay, so here's the point 0, 8. That's my y-intercept. If that's my y-intercept and this is the axis of symmetry that's going to act like a mirror, then there should be a mirror image of this point. This y-axis was 2 places away from the axis of symmetry. So if I go 2 places on the other side, I end up out here at 4. And so this point 4, 8 also has to be on the graph. Now, if I throw that together with my 2, -4 that I had for the vertex, then I have my vertex, I have a point on the left, a point on the right, should give me the ability to draw a pretty good representation of that parabola. Okay. On the second one over here, I do one on this side. Again, the idea, I'm going to go ahead and make the graph until I find a way to deal with not having the graph. And I'm going to say that this is the point 0, 13. So there was my y-intercept. That's 3 places to the right, so I need to move 3 places to the left, which is going to put me out here at -6. So this is the point -6, 13. And I know that has to be on my graph. My vertex was at -3, 22, which maybe if this is 22 up there, my vertex ends up being like that, and I would be able to sketch a reasonable looking parabola that goes through those points and looks reasonably symmetric as well. Okay, so that's how to do those problems. There's probably more explanation where I actually worked out the check your understanding, but if you were not here for the lecture part, that's what you missed.